x and y. dy dx. To integrate x, you need to put dx at the back. However, when you times by dx for the whole equation, it will become cos square x dy and bracket here and dx. That is not possible, so we make it 1 over cos square x here, but the dy changed by dx and integrate it as normal. For this, you will get ln y plus 3, supposedly plus c here, but when you integrate here, you will get the same plus c. You just need 1 c here, which is not for both equation got c, because c is constant. So when you solve it, you will get this as the final answer. To solve linear first order, what you need to do is you must check whether it's linear or not, and it must satisfy the first equation. This is the equation, which is y prime plus pxy and equal qx. It must be absolutely the same. After the number 1 step you have finished, you need to check for the second one, which is you need to find the px and the qx from the first equation here. Next, you need to find the integrating factor. I short it form as I dot f here, which is by writing mu x equal to exponential integrate px dx. Last but not least, we need to do the solution of mu xy equal to integrate mu x qx dx. I'm sorry, there's a mistake here. Here's dx. Here's the equation that we need to solve, which is dy dx minus y tangent x equal to exponential square. For the px, first what we need to do is we check is it linear or not. Okay, based on this equation, yes, it is linear because it satisfies the following equation here, right? So first, linear, check. Second, we find the px and qx. For this equation, the px is negative tangent x here, and the qx is exponential square. For the next step is we find the integrating factor, which is mu x equal to exponential px, which is negative tangent x dx. Then we solve it where we get this, and integrating negative tangent x is equal to integrate negative sine x over cos x dx. By using substitution method, we make u is equal to cos x and du over dx equal to negative sine x, du equal to negative sine x and dx. Then we substitute back into here, which is exponential integrate 1 over u du equal to exponential ln y. Exponential ln u. Next, by using the exponential rule, which is exponential ln will become u down here, it will become u, which is cos x here. So u equal to cos x. Done. Meaning that we already solved the number 3, the step 3. The final step is solution of mu x. Mu xy equal to integrate mu x qx dx. Here, mu x y equal to integrate cos x bracket e square exponential square dx. By referring up here, which is mu x and qx. Then we solve it normally, and lastly, we will get exponential square sine x plus c. This is the steps that you need to follow to solve the equation. How about when the equation is a non-exact or non-linear? So what we should do is, firstly, we need to change from the non-exact to exact. The first step you need to do is, you need to check whether the equation is exact or not exact. If it's exact, you need to use the same technique like before this. But if it is not exact, we proceed to the second step, which is, if none, we change. So by changing it, we use this formula, which is my minus nx divided by n, or nx minus my over m. So we got the equation here. Find for the integrating factor, which is exponential to the power of integrating the equation 1 or equation 2. So 1 or 2 is based on this one. This is 1 or this is 2. Okay? Choose either one. Later I will explain how or why. Then after you got for the integrating factor, multiply both by multiply the integrating factor with the original equation, then solve normally. So based on this question, we can see here it does not satisfy the first rule here, which is this: y prime, px, y, and qx. So what we should do, we need to solve it by changing from the non-exact to exact. So we arrange it like this. So as you can see here, the m is here, the first one, which is 2xy exponential x squared, and then the n is exponential x squared. For my, we differentiate it, with respect to y, where after you integrate this, you will get 2x exponential x squared. Besides, the next one is, we differentiate it with respect of x, and x respect of x. So as you can see, after exponential x squared, we will get 2x exponential x squared. So based on this, you can see my is equal to nx. It's supposedly equal because we're changing from non-exact to exact. So we write back fx xy equal to so we got this. We write it back and we integrate it. We put dx at the back. Now we are using the substitution method, where y, we let it out, and then 2x dx, we let u as x squared here. So we solve it. We got as du equal to 2x dx. Okay, let me show you here. Du equal to x squared, du over dx equal to 2x, du move the x here, become 2x dx. So we substitute to the question here. We get y exponential u plus gy. Remember, you need to put gy at the back of the equation. Then substitute back the u from here inside here. Y exponential x squared plus gy. Next, we solve the next one, which is the n. Fy bracket x, comma y equal to n equal to exponential x squared. We integrate the exponential x squared. You will, by the easiest way is you let the ex squared out, and then you integrate 1. You will get obviously y, and then you put inside, and you will get this as the final one, which is y exponential x squared plus hash x. So guys, as you can see here, for fx you need to put gy, and for fy you need to put the hash x at the back, because you are going to solve it. I mean, like you are going to calculate it after this. So the next one you need to do is by comparing. Take the fx equal to this equal to fy, and then you can see here there's two same thing you can cancel out. You can see here, so you compare. For gy is equal to 0 because there's no match here, and hash x equal to 0, no match, so both equal to 0. What you need to do for the final one is the general equation. For the general equation, there's no y or x down there. fxy equal to y exponential x, because the gy is 0 and hash x 0, you will make it like this: y exponential x squared plus 0 where's there's nothing equal to c. So this is the final solution on how to solve an equation which is non-exact. Thank you.